Have you ever wondered how traffic light always seem to know when to turn to color red, yellow or green, keeping traffic flowing smoothly without anyone controlling them? Today, I'm going to show to you that it's all thanks to a simple but powerful machine, which is Finite State Machine. Today, I'm going to present a Finite State Machine. The project I choose is Traffic Light Controller. Without further ado, a finite state machine is a mathematical model used to describe the behavior of systems that operate through a finite number of well-defined states. At any given time, the system exists at only one state and changes to another state based on the specific inputs or conditions. FSM are widely used in the computer science, software engineering, and in digital system designed due to their clarity and structured logic. The example I chose is a traffic light controller, which is a common real-world application of a finite state machine. By representing the traffic light system using states and transition, and then the operation of system can be clearly analyzed and understood. Traffic light finite state machine has three states, which is red, green, and yellow. Each state represents which traffic light is currently active. And this finite state machine uses a timer signal, which is T, as its input. So T equal to 0 meaning that the timer is expired, and then when T equal to 0, the timer is not expired, it's still going. And then each state produces a specific output, which is S0, red light is on, S1, green light is on, and then S2, yellow light is on. This table shows how the finite state machine, or as we call it FSM, moves between states. As we can see, the state S0, which is red, the system stays in red while the timer is running. That is when input is 0, and then once the timers expire, input is 1, it transitions to S1, which is the color green. State S1, which is green, the system remains green when input is 0 until the timer expired input 1, moves to the system S2, which is yellow. Same goes to S2, the system remains in yellow when input is 0 until the short transition timer expires, which is input 1, and then circling back to S0, red, to restart the sequence. If you still don't understand, let's go ahead with a visual representation. This diagram visually represents the finite state machine. The system starts at red and then moves to green and then yellow and finally back to red. Each arrow represents a transition caused by the timer. And since traffic light has a continuous cycle because it starts at red, yellow and then green and then go back to red, and then it never stops. Repeat it forever to manage traffic. Hence, it does not have a final state. Each arrow represents a transition caused by the timer. Here, we can see how the FSM operates dynamically. Each time the timer expires, the FSM moves to the next state in sequence. This FSM is important because it ensures traffic safety and efficient. The practical significance of this project that traffic light FSM ensures that orderly vehicle movement, and then it can reduce accidents and also predictable and reliable traffic control. FSM models like this are widely used in embedded systems due to their simplicity and reliability. That is all for me. I hope this video enlightens you about FSM and how it works. Thank you for watching.